here, what I can do is I can draw an x, I can do negative 50, again that's a times c, and then I can do b on the bottom, so that's 5. And so you want to think about what two numbers when multiplied equals the top, but when added together equals the bottom. Okay. Does anyone have any numbers here? Austin?
Would it be negative 10 and 5?
Ooh, so close. Alright, Riku, you want to tell us since you raised your hand? So, thank you, Riku, for raising your hand.
Yeah, Riku.
Okay, so here you would write this as, if you factor this as x plus 10 times x minus 5 equals 0. Wow, this is so clear. And then you would go ahead and set x plus 10 equals 0 or x minus 5 equals 0. And then you would solve. So again, what does this mean to have this as an answer? There are really two different questions here. One of the questions is that if you are given something like this problem where it says x squared plus 5x minus 50 equals 0, and they're asking us to solve, what we're solving for is when is this statement true? When is x, what value of x should x have so that the whole left side is equal to 0, right? So again, this is a truth statement. It's asking us what value of x do we need to make this statement true? Where does the left-hand side equal to 0 also? And if you plug in either one of these values in for x, you will get the left-hand side is equal to 0. The second thing we could solve for is if we were given y is equal to x squared plus 5x minus 50. And in this scenario, instead of solving for when the statement is true, what we're solving for is when this line, when this parabola crosses the x-axis. So this one is actually asking us, well, if a graph looks something like this, when does it cross these points right here, right? That's actually what they're asking us there. Okay. So in this way, I knew to use this method because I could easily factor it using the x method. And so clue number one is that if you are able to factor it like this, then just use this method. This should be your default method, right? This is your default delivery or whatever. In this case, you should also always default to this if you can because it's the fastest, the quickest, the easiest way. So you can see that for number 2, if I try to do the same thing, I draw an x, I put the negative 3 on the top, I put the 5 on the bottom, and I try to think about two numbers that multiply to equal negative 3, but when added together equals 5, I'm stumped. I don't know any number that does so. I don't know any number that does so. At least not at the top of my head, right? All the factors for 3 are 3 and 1. I can't really add them together to equal 5. I can't, it doesn't really work out. So in this case, where I'm stuck on number 2, I might think, oh, completing the square. If you're thinking about completing the square, you can do so. However, you are going to end up with fractions. And I know how much you guys love fractions. So if you hate fractions, I would stay away from using completing the square. Okay. However, if you're feeling adventurous, you can use completing the square for this one. With fractions, it is a bit of a journey, but you can still do it. For this one, if neither one of those work, completing the square does not work, factoring does not work, and I will tell you that for square root, it should already be set up for you so you can square root pretty easily. This one is not set up for you to use square root. In that case, your last method, even though it is a what I call a cure-all, it can actually solve any quadratic formula. Like it can solve any quadratic. Okay. The reason I just stray away from it is because it is, I think, the longest. It is really straightforward, but then we would use the quadratic formula. So you have z squared plus 5z minus 3 equals 0. In this case, you would just go ahead and label a is equal to 1, right? This is equal to 1. B is equal to 5 right here. And c is equal to negative 3, which is right here. You can quickly just label 1, 5, and negative 3, and then you would have x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So hopefully today we will spend some time trying to memorize it. I will try to use a memory mnemonic here. Did anyone solve for it and get this as an answer? So remember that last week I put up a challenge problem. The challenge problem was to actually complete the square and actually create the formula. Did anyone actually create the formula from completing the square? If not, that's totally fine. It is. So what you can do is you can actually derive this formula from y equals ax squared plus b of x plus c. Okay. Very interesting. Okay, so the next thing you do is just plug it in. So wherever you see b, you plug in 5. So you go negative 5 plus or minus. B squared is 5 squared minus 4, 1, negative 3, all over 2 times 1 equals negative 5 plus or minus 25 plus 12 over 2, and you get negative 5 plus or minus square root of 37 over 2, which looks like the ugliest answer in the world. You can't take the square root of 37. 37 is a prime number, meaning only 37 and 1 go into it. So we could just leave this as our answer. I will say that, again, just to remind you that this plus or minus means that there are two different answers. There is one where you add the square root of 37, and there's one where you subtract the square root of 37. Okay. So if you wanted to actually find the value of this, you could actually put this in your calculator. You can go negative 5 plus the square root of 37. Oops, already does the parentheses for you. Let's see. And you could say divided by 2, and you get an answer of 0.54. So you can see here that instead of writing 0.5413812651, I could write this out instead, right? One of my answers, x is equal to negative 5 plus the square root of 37 divided by 2. My other answer is exactly the same thing. The only difference is that I would also subtract the square root of 37. And you can see here that my other answer is actually negative 5.54138, etc. So if I wanted to give an estimate here, this one would be 0.54. And then I also have negative 5 minus the square root of 37 over 2, which is about negative 5.54. So you can see here that I actually have two answers that I can estimate, and it's actually a lot more accurate to represent it in this form because then I don't have to round my answer. And so that's why we always leave it in that form, even though it looks in a way unsatisfying because it's unresolved, but it actually has an answer of like 0.54 and an answer of negative 5.54. So again, what this means is that on the graph, those are the points in which it crosses the x-axis. So if I were to sketch my graph, I can see that it would cross about 5.5, which is about right here, and 0.5, which is right here. So you can see that my graph would look something like that. Right? I could just sketch my graph to look like that based on the x-intercepts. Right? Okay, so again, I use this method because 1, I could not factor. 2, I could not really complete the square without creating fractions. 3, it wasn't set up for me to square root both sides. So then I was like, okay, none of those methods work. I'm just going to use the quadratic formula. Okay. So 1, you could not factor. 2, it was not set up, or there's an odd number for 5z. That's an odd number, so it's hard. Number 3, it's not set up for square rooting both sides. And then 4, that's just the method we're going to use. Okay, number 3. So number 3 is x squared minus 14x plus 36 equals 0. I'm just going to go right off the bat and say that this one, even though it looks like you can factor it, factoring doesn't work. You're just stumped. You're completely stumped, right? You could factor it, and if you spend more than a minute trying to factor it, it's probably not going to work. So for this one, I can automatically think, okay, maybe I use quadratic formula or completing the square, right? For this one, I realize that negative 14 here is an even number, so I can go, okay, I'm going to complete the square because it's an even number. So what we want to decide is what number does 36 need to be, right? So what you do is you take half of negative 14 and then you square it. So negative 7 squared is 49. So that means I need this 36 to become 49. So what I should do is I should add a number so that 36 becomes 49. Joey? 13. So I add 13 to both sides, and I get x squared minus 14x plus 49 equals 13. As a reminder, this turns into x blank. And remember that this right here is always going to be half of this negative 14. So in this case, half of negative 14 is... Hopefully you all know 14 divided by 2. Joey again. It is 7. It's not just 7. It is negative 7. So this number, again, is always going to be half unless a is greater than 1. Okay, so I want you to see something here. This is kind of what we mean by square rooting both sides. Sometimes it's already going to be set up in this form, and that's when you're going to just say, I'm going to use the square rooting form. You can see here that we actually had to complete the square first to get to this point, and so this method would be called completing the square. Square root both sides is already at this point, and then you just move from this point on. Okay. So the next thing you would do is you would square root both sides. You would square root both sides. You would get equals plus or minus the square root of 13. X minus 7 equals plus or minus square root of 13. You could add 7 to both sides, and you get x is equal to 7 plus or minus the square root of 13. Again, there are two answers, x equals 7 plus the square root of 13, or x equals 7 minus the square root of 13. So you can see here that if I put it in my calculator, I have 7 plus the square root of 13, and you can see that that's about 10.6, right? I don't usually write it in this form because you can see here I need to round my answer, but to be even more accurate, I could just write 7 plus the square root of 13. And again, if I did the other one and I subtracted, then you could see here that my other answer is about 3.34, and so you can see that this one on the right is about 3.4, and the one on the left is about 10.6. Okay? So again, they're real answers, they just look really crazy. The reason we leave them in those forms is so we don't have to round the answers, okay? Because it's even more accurate to say the other parts. Okay, so this is 3 of the methods. So far we've done factoring, we've done quadratic formula, and third we've done completing the square. The one we just did was completing the square. The last method that we can do is square rooting, and it looks like I do not have anything right here. So I'm just going to give us an example problem. Let's just say, for example, we were given something like this. So if we're given something like this, this is how you know you should use the square rooting method. Okay, so this would be method 2. The reason you know you would square root this is because this is already given in this form where you have an x minus something squared, or you might have something where it's like, 2 times x squared plus 4, equals 16. So you might have something else also in this form, and that's how you also know you would use the square root ability. Okay, so in this case, you would just solve for the different parts. So you can see here what I do is I actually move from farther away, and then I move closer and closer, and it's actually like reverse PEMDAS. What I'm going to do is I'm going to first subtract from both sides first, and then I'm going to divide from both sides first, and then once it is isolated with just this portion, the parentheses with the square root, I would just square root both sides. So then it would be plus or minus. So here, remember that the square root of 8 can be turned into 2 times 2 times 2. So since there are two 2's in the square root, then I can change it to 2 root 2. So this is 2 root 2, x minus 4. I would add 4 to both sides. So my answer is x is equal to 4 plus or minus 2 root 2. And that is my answer. Yes. Question.
What happens if only the x is squared?
Okay, so there's this other case right here on the right. Focus in there. So in this case on the right first, I would deal with everything outside the parentheses first. You can see here I divide everything by 2. I get x squared plus 4 equals 8. Then I add minus 4 on both sides. And you can see here it's pretty much the same thing. You can see here that x squared equals 4. I'm just going to square root both sides. I get x is equal to plus or minus 2. So what I did is I just isolated the x squared, and then I eventually had x squared on one side, all the numbers on the other side, and then I just solved. So these are the two different ways you could do the square root. Again, the reason I knew that I should use the square root is because you can see here x squared was either by itself, or in this portion you can see x minus 4 was in parentheses and being squared. So this is when you know you're going to use this quote-unquote square root method, the square root method.